Hi, my name is Elson Yap. I am from AG and this is for Emath 1 project. So today we will be talking about the graph of quadratic functions using inputs b and c. So over here we have a graph which has actually two series. So there's series 1 and there's series 2. So our series 1 will be representing the x to the power 2, while series 2 will be representing the x to the power 2 plus bx plus c. So if I change our b value to a positive number, it will actually cause our curve to shift towards the left. Then, whenever I change our b to negative 3, which is a negative number, it will cause our curve to shift towards the right. Whenever I change the c value, it will actually cause the y-axis to change. This is due to c being the constant, so it won't be affected by our x's, x to the power 2, and our bx. So if I'll change our c to a negative 3, it will cause our curve to be shifted down by minus 3. And if I change the curve to a positive 3, it will cause the curve to shift up by 3. Okay. So there's also another thing. So we have a numerical discriminant over here. So if I just change it to... Okay. So as you can see over here, if b and c is both 3, our numerical discriminant over here will be negative 3. So whenever our discriminant is below 0, there will be no real solutions as shown over here. Both my x1 and my x2 will be counted as an undefined number. But if I want to have solutions, I can just change here. So 3, 0. Okay. So the numerical discriminant over here is 9. And since 9 is more than 0, this means that we'll actually have two real solutions, as shown over here, where our x1 is 0 and our x2 is a negative 3. But then, whenever, let's just change this to 4 and a 4 over here. So now our numerical discriminant is actually 0. And with the solutions over here, our x1 is negative 2 and our x2 is also negative 2. This will also show that our discriminant, whenever is 0, will only have one real solution. Thank you for listening through this presentation about the graph of quadratic functions.